Okay, welcome, and uh, let's do the sixth example in this course for the transformer. I don't know if you can see it from the light. It says a one-phase 100 kilovolt ampere 2200 volt two-winding transformer is conducted as an auto transformer as shown in figure, such that more than 2000 volt is obtained at the secondary. The portion AB is in the 200 volts winding, 200 volt winding, and the portion BC is the 2000 volt winding. Compute the kilovolt ampere rating as an auto transformer. So now we had a single phase transformer that is now reconnected as an auto transformer. In this way, I showed you in my last video how do you do it. You just connect one terminal of the secondary to the other of the primary, and then you can step up or step down the voltage. For example, if you wanted to step down the voltage, then on the primary would be from here to here, and on the secondary would be from here to here, the terminals. But in this particular situation, we are stepping up the voltage for okay. Now, first, it says that we need to compute the kilovolt ampere rating as an auto transformer. So we have to know what amount of power we can transfer if that single phase transformer is now as an auto transformer. Now we have to know what are the current ratings for the low voltage winding and for the high voltage winding. So from portion A to B was the 200 volt winding. Now what was the rated current for the low voltage side or the 200 volt side? Well, it is easy to calculate. That was the current from A to B is equal to the power, that is 100,000 volt amperes divided by the voltage, that is 200 volts on the secondary. No, not the secondary, but on the low 200 volt side, and this is 500 amperes. Now, from B to C, we just calculate it like this. Now, so these are the rated voltages over here. This is the IH current, 500 amperes. And on the low voltage side, we have Kirchhoff's first law. From the Kirchhoff's first law, we have that now this 2000 volt is the low voltage side because we have a higher voltage on the secondary, and the low voltage side current is 500 amperes plus 50 amperes, and that is 550 amperes. Okay. Now, as you can see, now it says what is the kilovolt ampere rating of a transformer. That is easy to calculate. That is the apparent power, and let's calculate from the low voltage side and the high voltage side. So kilovolt from the low voltage side is equal to the low voltage current times the low voltage side current voltage, the low voltage side voltage times the low voltage side current, and that is equal to 2000 times 550, that is equal to that is equal to 1100 kilovolt ampere. Okay, this marker is dead. And the kilovolt ampere rating from the high voltage side, this side, is equal to the VH times IH, that is equal to 2200 volts times 500 amperes, and that is equal to 1100 kilovolt amperes. Now, as you can see, as an auto transformer, the kilovolt ampere ratings is in this particular situation 11 times higher than as a single phase transformer. So as an auto transformer, you can transfer more power to the output if you step up the voltage in this particular situation, but and auto transformers have lower internal resistances and heating problems than the single phase transformer. But the biggest problem is if you don't have electrical insulation, but you need one electrical insulation, then you cannot use a single phase transformer as an auto transformer. Okay, so that is it for this video. In my next video I'm going to show you the 3-phase transformer. So see you in my next video. Goodbye.